First question, consider separate solutions of 0.5 molar C2H5OH and 0.1 molar Mg3PO4 twice and 0.25 molar KBr and 0.125 molar Na3PO4 at 25 degrees Celsius. Which statement is true about these solutions assuming all salts to be strong electrolytes? And when you look at the option, you will understand that this question is from solution, theory of dilute solution, and here if you look at that option you can see the term osmotic pressure in all the options. So it's about osmotic pressure. You know that osmotic pressure is a colligative property, a quality which depends on the quantity, not on quality. So here what matters is how many particles are there in the solution. So what is the equation that represents osmotic pressure? Pi is equal to CRT. Here why they have included this problem is, for this electrolyte you are going to get abnormal molecular mass. The abnormality is due to dissociation of the particles into ions. You will be expecting one particle but you will be getting many particles, so that you have to multiply with 1/2 factor. So if you take first option, before that you have to take how many particles are there. How many particles are there? Mg3PO4 twice, dissociating how many particles you will get? 5. And what is the molar concentration? 0.1. Okay, and we will take RT as it is. Okay, and this is the first case, pi 2. What is the molar concentration? 0.125. And how many particles are present? 4. So 4 into 0.125 RT. And what about the third one? C2H5OH means how many particles? Only one particle, because it is a weak electrolyte, it dissociates very weakly. So 1 into 0.5 RT. So what is the last option? They all have the same osmotic pressure. Do you agree with that? So if you take for all of them, you will get 0.5 RT. When it is 0.5 RT, all of them are having same osmotic pressure. Or even you can look at what is the number of particles just by multiplying the 1/2 factor. 1/2 factor means how many particles will be produced by the dissociation. Okay, multiplied by 1/2 factor. Fine. So what is the option? D option. So there is a, which one of the following bases is not present in DNA? And the bases present in DNA could be remembered by ATGC. What is ATGC? Adenine, thymine, then G for guanine, and you may confuse with quinoline. That's why quinoline is a heterocyclic compound where nitrogen atom is present. Pyridine, do you remember? One more benzene ring is fused with that. That's how you get quinoline. And guanine is supposed to be the base, but what is given? Quinoline. So quinoline is not a base which is present in DNA. Next one. Considering the basic strength of amines in aqueous solution, which one has the smallest pKb? So how do you relate the basicity with Kb? As Kb increases, basicity also increases, right? What about pKb? As pKb value decreases, basicity increases. So you have to select the strongest base or weakest base? Strongest or weakest? Yeah, you have to select the strongest one. And if you take C6H5NH2, you know that it is attached with benzene ring, and it will be involving in what type of effect? Resonance effect. Resonance effect means what type of resonance effect? Plus R. So basicity means it depends on the availability of this pair of electron. Bases donate pair of electron, and it depends on the availability of this pair of electron, and you know that this pair of electron, it is involved in resonance. What type of resonance? Plus R, and it is already deposited in resonance. So the availability of this pair of electron is least, so that its basicity is least. And when you take all other CH3NH2, CH3 thrice N and CH3 twice NH, if you take these three are basic, strongly basic, right? Comparatively all of them are basic, and among these three, which one is more basic? And there are two factors you have to consider. One is the positive inductive effect. According to positive inductive effect, which one will be more basic? So I repeat, the basicity depends on the availability of this pair of electron. When you write NH2, CH3 NH2, here this pair of electron is available because of the CH3 will giving a plus I effect. So if you take CH3 thrice, CH3 and CH3 twice, which one is more basic? There it is, according to, if you are taking only inductive effect, you will find that B option is more basic, right? Because 3 methyl groups are pushing, supplying electrons to nitrogen, and it facilitates the losing of electron. But the answer is D. Why D is the answer? There is a possibility of hydrogen bonding in water molecule. In aqueous solution, it is told. So when it is in aqueous solution, the availability of electron will be more in case of D option. Have you understood? If you are taking only plus I effect, which is the answer? B is the answer. In that case, hydrogen bonding is not that much facilitated because of that bulkiness.